Friends, myself Dattatreya Jadhav. I am from HM College, Karad. During our previous video, we have learned about substitution theorem and its corollaries. Okay, today we are going to find integration of tanx, integration of cotx, integration of secx, integration of cosecx. We know integration of sine x and cosec, but we don't know about integration of tan, cot, sec and cosec. So starting with integration of tan x. Okay, here is the first one. Evaluate integration of tan x dx. Okay, first denote the given integration by I. So starting with let I is equal to integration of tan x dx, where here given integration of tan x dx. To find the formula for integration of tan x dx, first step is write tan x as. We know that tan x can be written as its sin x upon cos x. So I can write this as sin x divided by cos x dx. Okay. In any example of integration, first try to check whether the substitution is possible or not. In substitution, find the function and its derivative inside the integration. Here is the function cosec and derivative of cosec is sin x dx. Okay. But when we substitute for sin x, derivative of sin x is cos x, but we want the term dx into. So proper substitution, okay, is put cos x is equal to t. Okay, since derivative of cos x is sin x dx, on differentiating, derivative of cos x is what? Minus sin x. Okay, derivative of cos x is what? Minus sin x. Since it is differentiated with respect to x, so multiplied it by dx is equal to derivative of t is what? 1. Since it is differentiated with respect to t, multiplied it by dt. But there is only term in our integration, it's sin x dx. Okay, so we find only value of sin x dx. Yes, sin x dx is equal to, multiplying both by side by minus 1, so sin x dx is minus 1. So our integration becomes integration of sin x dx can be written as minus dt divided by, yes, instead of cos x I can write here t. Minus sign constant, take outside the integration, it looks like 1 upon t dt. Okay, therefore I is equal to, yes, we know that integration of 1 upon x dx is what? Integration of 1 upon x dx is log of mod x plus c. Integration of 1 upon t dt is what? Integration of 1 upon t dt is log of mod t plus c. Okay, now answer of the given integration is in t because of our substitution. So resubstitute the value of t, which is equal to minus log of mod of, what is t? It's cos x plus constant of integration c. Okay, so remember one formula, integration of tan x dx is equal to minus log of mod cos x plus. Okay, now I can simplify the formula as it looks like minus 1 into log of mod of cos x plus c. Okay, minus 1 into, and we know that n in log m is nothing but log of m raised to n. So here minus 1 is coefficient, it's n, log cos x is n. So I can write this as log of mod of cos x raised to minus 1 plus c, which is equal to log of mod of cos x raised to minus 1 is nothing but 1 upon cos x plus constant of integration c. And we know that 1 upon cos x is, yes, 1 upon cos x is sec x. So log of mod of sec x plus c. So integration of tan x dx is log of mod of sec x plus c. Okay, there are two formulas for integration of tan x dx. Either you can write minus log of mod of cos x plus c, or you write log of mod of sec x plus c. Okay, now next evaluate or find the formula for integration of cotx dx. Integration of cotx dx. Yes, we are already know that. We already know that. First, denote the given integration by I. So starting with let I is equal to integration of cot x dx. Okay. Now, yes, cot x can be written as it's cos x divided by sin x. Okay. Now we know that. What we know that? Derivative of sin x is cos x dx. Okay, derivative of sin x is what? Cos x dx. So put for which term the function whose derivative is there. Since derivative of sin x is cos x, so putting sin x is equal to another variable t. On differentiating, okay, on differentiating, here in LHS there is sin x term of x, so we differentiate with respect to x. Derivative of sin x is what? It's cos x. Okay, since it is differentiated with respect to x, LHS is differentiated with respect to x, so multiplied it by dx is equal to derivative of t is what? 1 with respect to t. So multiplied 1 by dt. 1 into dt is dt. So on differentiating we get cos x dx is equal to dt. Here is that term, cos x dx. So integration becomes I is equal to cos x dx. I can write instead of cos x dx it's dt divided by sin x. For sin x we substitute t. So here it looks like 1 upon t dt, and we know that integration of 1 upon x dx, integration of 1 upon x dx is what? Log of mod x. Integration of 1 upon t is log of mod t plus c. But answer is in t, variable t, because of our substitution. So resubstitute the value of t. So which is equal to log of mod of what is t? It's sin x. So log of mod of sin x plus constant of integration c. Here is the formula for I is what? Integration of cot x dx. So integration of cot x dx is equal to log of mod of sin x plus c. Here is the second formula for integration of cot x. Okay. Now another formula is for integration of cosec x. Okay, to find integration of cosec x. So starting with let I is equal to integration of cosec x. So here remember one step. When to find integration of cosec x and sec x, tell me the derivative of cosec x. Yes, the derivative of cosec x is minus cosec x into cot x. That minus put in between these two terms. That is, the term is cosec x minus cot x. And remember that multiply numerator and denominator by cosec x minus cotx. Why? Let's see. After multiplying numerator and denominator by cosec x minus cotx, so it becomes I is equal to cosec x into cosec x minus cot x divided by cosec x minus cot x dx. On multiplying numerator and denominator by cosec x minus cot x. Why we multiply by cosec x minus cot x? Because we know that derivative of cosec x is minus cosec x into cot x, and derivative of cot x is minus cosec square x. Minus minus becomes plus. It's cosec square x. Taking what common? Cosec x. So taking cosec x common, what's remaining here? Cosec x, and here minus cot x, means derivative of cosec x minus cot x is cosec x into cosec x minus cot x. That's why we multiply numerator and denominator by cosec x minus cot x. Remember here, for finding the integration of cosec x, we multiply numerator and denominator by cosec x minus cot x. Okay. Now we have already known that derivative of cosec x minus cot x is, yes, cosec x into cosec x minus cot x. So putting cosec x for the term cosec x minus cot x is equal to t. On differentiating, we get derivative of cosec x is minus cosec square x. Okay, minus derivative of cot x is derivative of cosec x is minus cosec x into cot x, and derivative of cot x is minus cosec square x. Since it is differentiated with respect to x, so multiply it by dx, and derivative of t is what? 1. Since it is differentiated with respect to t, multiply it by dt. So after simplification, we write minus minus becomes plus cosec square x plus second term minus, yes, cosec x into cot x dx is equal to dt. After simplification, yes, taking what common? Cosec x. Inside the bracket, it's what's remaining? Cosec x, and here is cot x. So cosec x into bracket cosec x minus cot x dx is equal to dt, and here is that term cosec x into cosec x minus cot x dx. Instead of this term, we write dt. So integration becomes I is equal to instead of cosec x into cosec x minus cot x dx, we write here dt divided by, instead of cosec x minus cot x, it's t. Okay. Now example is a new variable t. So I is equal to, I can be written as, yes, it looks like 1 upon t dt. dt upon t is nothing but 1 upon t dt. And we know integration of 1 upon t is log of mod t. So log of mod t plus c. But answer is in variable t because of our substitution. So resubstitute the value of t. So integration becomes log of mod. What is t? It's cosec x minus cot x. So integration of yes, cosec x dx is equal to log of mod of cosec x minus cot x plus c. It's our first formula for integration of cosec x dx. Okay. After simplification, the second formula for cosec x into cotx, consider this equation as a 1. Okay, now look at here. We have cosec x minus cotx is what? Cosec x minus cotx is equal to, cosec x is it's 1 upon sine x, and cotx is what? Cosec upon sine x. Here denominators are same, so I can write this as, yes, denominator is same, it's sine x, 1 minus cos x. We know that 1 minus cos theta, 2 sine square theta by 2, so 2 sine square half of the angle. And we know that about sine theta, 2 sine theta cos theta. For sine x, I can write this as 2 sine x by 2 into cos x by 2. The term 2 get cancelled. One sine in numerator and one sine in denominator get cancelled, and we remaining it's sine upon sine x by 2 divided by cos x by 2. So it's what? Tan x by 2. Here the value of cosec x minus cot x is tan x by 2. So another formula for integration of cosec x dx is equal to log of mod of, instead of cosec x minus cot x, I can write this tan x by 2 plus constant of integration c. Here is the second formula for integration of cosec x dx, log of mod of tan x by 2 plus c. You use any one of these formulas. Okay. Next, to find integration of secx, or to find the formula for integration of secx dx. Okay. So first denote the given integration by I. So let I is equal to what? Integration of secx dx. In previous example, we see for finding integration of cosec x, we multiply numerator and denominator by, yes, cosec x minus cot x. Now, for finding the integration of sec x, tell me first derivative of sec x is what? Derivative of sec x is sec x into tan x. What is the sign? It's plus. Take that plus in between these two terms. So what we get? Sec x plus tan x. Okay. So multiply numerator and denominator by sec x plus tan x. Why we multiply numerator and denominator by sec x plus tan x? The answer of that question is yes, because derivative of sec x plus tan x is, yes, look at here, after substituting put sec x plus tan x is equal to t on differentiating, because we have already know that derivative of sec x plus tan x. Look at here, derivative of sec x is, yes, it's sec x into tan x plus derivative of tan x is sec square x. Since it is multiplied, since it is differentiated with respect to x, so multiply it by dx is equal to derivative of t is 1. When it is 1, when it is differentiated with respect to t, so multiply it by dt. Taking what common? Taking sec x common. When we take sec x common from second term, it's remaining sec x, and when we common sec x from first term, the remaining is tan x dx is equal to dt. So sec x into sec x plus tan x dx is equal to dt, and here is that term sec x into sec x plus tan x dx. Okay, instead of that term I can write dt. Okay, so integration becomes I is equal to dt divided by, for sec x plus tan x it's only t, upon t is nothing but si is equal to dt upon t is nothing but 1 upon t into dt. Tell me integration of 1 upon x. Integration of 1 upon x is log of mod x. So integration of 1 upon t is log of mod t plus c, which is equal to log of mod of. Replace the value of t by secx plus tanx. Log of mod of secx plus tanx plus constant of integration c. And what is I? I is nothing but integration of secx dx. Okay. It's our formula for integration of secx dx. Equation number first. After finding the value of secx plus tanx, write secx as secx is nothing but 1 upon cosec plus tanx as sin x upon cosec. We get another formula for integration of secx dx is equal to log of mod of tan of pi by 4 plus x by 2 plus constant of integration c. It's another formula for integration of secx dx. So simplifying secx plus tan x, okay, it's for more. Okay, next we are seeing some examples on substitutions here. First example, starting with first example, evaluate integration log of x bracket raised to n divided by x dx. Okay, so this is our first question. Evaluate integration log of x bracket raised to n divided by x dx. Okay, first check the example is of integration. Which type of integration is given? Algebraic or trigonometric? Okay, if algebraic is there or trigonometric is there, make sure there is possible any substitution, and for substitution find the function and the derivative of that function inside the integration. Okay, first it is example of integration. So starting with let I is equal to integration of log x bracket raised to n divided by x dx. Okay, so here we know that derivative of log x is 1 upon x. Okay, that's why we substitute for log x. Put log x is equal to another variable, that is t. When we substitute log x is equal to t on differentiating, tell me the derivative of log x. Derivative of log x is 1 upon x. When it is 1 upon x, if the function is differentiated with respect to x, so multiplied LHS by dx, since it is differentiated with respect to x. And here derivative of t is what? 1. Because the function is in t, so we differentiate with respect to t. Derivative of t is what? 1. When it is 1, if the function is differentiated with respect to t, so multiply it by dt. 1 into dt, so dt. Look at here. 1 upon x dx. Here is that term. 1 upon x dx. Instead of 1 upon x dx, we write dt. And instead of log x, we write t. So integration becomes t raised to n and 1 upon x dx is nothing but dt. Okay? Log x is equal to t. So it becomes t raised to n and 1 upon x dx is dt. Clearly, example of the integration is in new variable t. So, integrate. We know that integration of x raised to n is x raised to n plus 1 upon n plus 1. So, integration of t raised to n is what? T raised to n plus 1 divided by n plus 1 plus constant of integration c. But answer is in t. So, resubstitute substitute the value of t as log x. Therefore, answer of the given question is log x bracket raised to n plus 1 divided by n plus 1 plus constant of integration c. Here is the final answer of the given question. Integration of log x raised to n divided by x dx is equal to log x raised to n plus 1 divided by n plus 1 plus. ओके, नक्की काय करायचं सबस्टिट्यूशन मध्ये? तर सबस्टिट्यूशन या टाइप मध्ये आपण फक्त काय करायचं आहे, एक फंक्शन असं शोधायचं आहे इंटिग्रेशनच्या एक्झाम्पल मध्ये की त्याची डेरिव्हेटिव्ह इंटिग्रेशनच्या एक्झाम्पल मध्ये असणं गरजेचं आहे किंवा त्या डेरिव्हेटिव्हचा पार्ट. ओके, तर आपण अशा फंक्शन बद्दल सबस्टिट्यूशन करून एक्झाम्पल सॉल्व्ह करू शकतोय. नेक्स्ट एक्झाम्पल, इव्हॅल्युएट इंटिग्रेशन. इव्हॅल्युएट इंटिग्रेशन 10x raised to 9 plus 10 raised to x log 10. 10x raised to 9 plus 10 raised to x log 10 divided by, yes, divided by 10 raised to x plus x raised to 10. 10 raised to x plus x raised to 10 dx. Okay, starting with, yes, starting with let I is equal to, because it is the example of integration. Starting with I is equal to, let I is equal to, yes, integration of 10x raised to 9 plus 10 raised to x into log 10 divided by 10 raised to x plus x raised to 10 dx. Okay, find, okay, example on algebraic type. So first find, check whether the derivatives are present inside the integration. Yes, we know that derivative of 10 raised to x is 10 raised to x log 10 and derivative of x raised to 10 is 10 into x raised to 9. So derivative are present inside the integration. That's why we use substitution method here. So put for the function whose derivative is there. Whose derivative is there? The derivative of 10 raised to x plus x raised to 10 is there. So put 10 raised to x plus x raised to 10 is equal to t. On differentiating. On differentiating, what we get? Derivative of 10 raised to x is 10 raised to x into log 10 plus derivative of x raised to 10 is 10 into x raised to 10 minus 1, that is 9. Since it is multiplied, since it is differentiated with respect to x, multiplied by x, and derivative of t is what? 1. When it is differentiated with respect to t, so multiply 1 by dt. So 1 into dt is nothing but dt. And here is that term. Integration of 10 raised to x raised to 9 plus 10 raised to x log 10 divided by 10 raised to x plus x raised to 10 dx. And here is the term of the differentiation. Okay, so instead of that term, I can write dt divided by, and 10 raised to x plus x raised to 10, we can write here t. It's nothing but 1 upon t dt. Integration of 1 upon t dt is log of mod t plus constant of integration c. But what is t? T is nothing but log of mod of. T is what? 10 raised to x plus x raised to 10. So here is the final answer of the given question. Okay. Next, third example is here. Evaluate integration. Evaluate integration sine inverse x bracket raised to 3 by 2. Evaluate integration sine inverse x bracket raised to 3 by 2 divided by root of 1 minus x square dx. Okay. तर इंटिग्रेशनचं एक्झाम्पल आलं तर काय करायचंय? पहिल्यांदा तुम्ही साध्या आणि सोप्या पद्धतीने दिलेल्या इंटिग्रेशनचं व्हॅल्यूचं एक्झाम्पल I इज इक्वल टू डिनोट करून घ्यायचं आहे आणि त्याच्यानंतर चेक करायचंय की ते एक्झाम्पल अल्जेब्राइकचं आहे का ट्रिग्नोमेट्रिकचं आहे. कोणतंही असू दे आपल्याला सबस्टिट्यूशन होते का बघायची. सबस्टिट्यूशन कोणाबद्दल करायची, जर त्या फंक्शनची डेरिव्हेटिव्ह त्या एक्झाम्पल मध्ये असली पाहिजे. ओके, सो स्टार्टिंग द सोल्युशन इज हियर. लेट I is equal to integration of sine inverse x bracket raised to 3 by 2 divided by root of 1 minus x square dx. We know that derivative of sine inverse x is what? Derivative of sine inverse x is 1 upon root of 1 minus x square. So we substitute for the term sine inverse x. Put sine inverse x is equal to t. On differentiating, we get, yes, derivative of sine inverse x is 1 upon root of 1 minus x square. Since it is differentiated, that is LHS is differentiated with respect to x, so multiply by dx, which is equal to, in RHS there is t, derivative of t is 1 when it is differentiated with respect to t. So multiply RHS by dt. 1 into dt is nothing but dt. Here is that term 1 divided by root of 1 minus x square dx. 1 divided by root of 1 minus x square dx. Instead of that term, okay, we write dt. So integration becomes sine inverse x, it's t raised to 3 by dt. Okay. Now we know that integration of x raised to n, integration of x raised to n is x raised to n plus 1 upon n plus 1. Integration of t raised to 3 by 2, t raised to 3 by 2 plus 1 divided by 3 by 2 plus 1 plus constant of integration c, which is equal to t raised to 3 by 2 plus 1. It's nothing but 5 by 2 divided by 5 by 2 plus constant of integration c. After simplification, we get I is equal to 2 divided by 5 t raised to 5 divided by 2 plus c. Okay, now replacing t by sine inverse x, because question is in x, so it's 2 divided by 5 into sine inverse x bracket raised to 5 by 2 plus constant of integration c. Here is the answer of the given question. Integration of sine inverse x raised to 3 by 2 divided by root of 1 minus x square dx is 2 divided by 5 into sine inverse x raised to 5 by 2 plus c. Next example is here. Evaluate integration of x raised to 9 into sec square of, evaluate integration x raised to 9 into sec square of x raised to 10. Okay. First denote the given integration by I. Let I is equal to integration x raised to 9 into sec square of x raised to 10 dx. Okay. Now examine whether the substitution is possible or not. Find the function and its derivative. Yes, we know that derivative of 10 x raised to 10 is what? Derivative of x raised to 10 is 10 into x raised to 9, and here is the part of x raised to 9. Okay, if constant is there, forget it. Okay, so put x raised to 10 is equal to t. On differentiating, derivative of x raised to 10 is nothing but 10 into x raised to 10 minus 1, that is 9. Since it is differentiated with respect to x, multiply it by dx is equal to derivative of t is 1, since it is differentiated with respect to t, so multiply by differential dt to 1. 1 into dt is dt. Okay, now look at here, but there is only term x raised to 9 into dx. So I can find only value of x raised to 9 into dx. Therefore, x raised to 9 into dx is nothing but dt divided by 10. Okay, x raised to 9 into dx is equal to dt divided by 10. Instead of x raised to 9 dx, I can write dt divided by 10. And for sec square, as it is for x raised to 10, we write t sec square t into x raised to 9 dx is nothing but dt divided by 10. Now, here 10 is what? Constant. Take outside the integration. So, next step is 1 upon 10 into integration of sec square t dt. Okay, here 1 upon 10 as it is, and tell me the integration of sec square x. Integration of sec square x is nothing but tanx. So integration of sec square t is tan t plus constant of integration c. Here 1 upon 10 is constant as it is, and tell me answer is in t. So resubstitute. Question is in x. So resubstitute value of t as x raised to 10. So answer is 1 upon 10 into tan of x raised to 10 plus constant of integration c. It is our final answer of the given question. Okay. Next, one more example is here. Evaluate integration of e raised to 3 log x, e raised to 3 log x into x raised to 4 plus 1, x raised to 4 plus 1 bracket raised to minus 1 dx. Okay. First, denote the given integration by I. So starting with, let I is equal to integration of e raised to 3 log x into x raised to 4 plus 1 raised to minus 1 dx. Converting negative power in terms of positive one, so it becomes, yes, in denominator x raised to 4 plus 1. And look at here. Here the base is e and power is log. We know that exponential function and logarithmic functions are inverse of each other. When they came, they cancel with each other. So I use here n log m is equal to log of m raised to n. Okay, here is 3, so I can write this as e raised to log x cube. When they came in front of each other, they get cancelled when there is no term in between these two functions, exponential and logarithm. There is no any term. Why? Because we write p at the power of x using the formula n log n is equal to log of m raised to n. Now what happened? Exponential and logarithmic functions are cancel with each other, and what's remaining? It's x cube divided by x raised to 4 plus 1 dx. Here is the reason. E raised to log of any number, that is x to the base e, is equal to x. If base of the number and base of the logarithm are same, then they cancel with each other, and remaining term is x. Okay. Now look at here. The example of the integration is, yes, which type of integration? Algebraic integration. Is there is a possibility of substitution? Yes. Why? Because derivative of x raised to 4 is 4x cube, and here is the term of x cube. Forget about that 4. Okay. So put proper substitution is put x raised to 4 plus 1 is equal to t. Why we take 1 here? Because derivative of constant is 0. So So put x raised to 4 plus 1 is equal to t on differentiating. Derivative of x raised to 4 is 4x cube plus derivative of 1 is 0. Don't write. Since it is differentiated with respect to x, multiplied by dx is equal to dt. But there is only term of x cube x dx. So find only value of x cube x dx. X cube x dx is equal to dt divided by 4. Okay. Now the integration becomes what happens here? I is equal to integration of, instead of x cube dx I can write this as dt divided by 4 whole divided by, instead of x raised to 4 plus 1 here is t. So we know that denominator of numerator comes in denominator, so it becomes dt divided by 4t, which is equal to 1 upon 4 is constant and dt divided by t is nothing but 1 upon t dt. 1 upon 4 is constant into integration of 1 upon t is what? Integration of 1 upon t is log of mod t plus constant of integration c. But answer is in variable t because of our substitution. So resubstitute for t. T is what? X raised to 4 plus 1. So answer is 1 upon 4 into log of mod of x raised to 4 plus 1 plus constant of integration c. Here is the final answer of the given question. I hope you have understand all these examples and you revise the formulas of integration of tanx, integration of cotx, integration of secx and integration of cosecx. Okay, so revise all these formulas.